Thank you very much, Jennifer. As Rebecca Dell pointed out, the steel industry is the industry sector responsible for the largest carbon emissions globally. And our next speaker represents ArcelorMittal, the largest steel company in the world. At this time, there's only one commercial scale carbon capture operation at a steel plant in the world today, and it is Emirates Steel in the United Arab Emirates. The next project, number 2, is under construction in Belgium, and it is a partnership, as Jennifer pointed out, between ArcelorMittal and LanzaTech. Tom Dower will talk about how his company sees carbon capture and utilization as a way to add value to commodity steel production, and will share details of their commercial project now under development. Tom represents ArcelorMittal in Washington and is active in efforts to advance federal policy in this arena. Prior to that, Tom served as staff to Senators Rockefeller and Specter, and he was actually involved in the early legislative efforts to reform the 45Q tax credit, the very early ones. And many of us tease Tom that he's our man of steel in Washington. So please help us welcome Tom Dower.
Thank you, Brad. Yes, I got to know Brad and a number of other people in the room by being lobbied by you to do things over the years, and congratulations on all that work, because it led somewhere, but only after I was gone. I'm going to add my water bottle for my Marco Rubio moment. That's a Washington joke, sorry. So, of course, it's in the way. There it is. So thank you very much for having me here. As Brad mentioned, I worked for John D. Rockefeller IV, so this is a really special moment for me to be here, because Senator Rockefeller has told me so much about this incredible place that we are, and it's really important. So thanks, double thanks. And as I stand here, I'm sort of acutely aware of the difference between political science and, without offending any political scientists in the room, sort of real science and engineers. To follow Jennifer and Rebecca and Jonathan and others, it's really an honor to be here with such great thinkers. And I do feel a movement happening in this room, which sort of heartens me for the future of this issue, and really the future for my children and our whole civilization. So ArcelorMittal is the world's largest steel and mining company. One of our guiding principles is to produce sustainable steel. And we are the leading supplier of steel in all major markets, such as automotive, construction, household appliances, packaging. We have an industrial footprint in 19 countries with over 200,000 employees. And I should also add that in 2018, we were responsible for over 200 million tons of CO2 emissions. Those are scope 1 and 2. I've been on other panels with other industries where they say 96% of their emissions are scope 3, which presents its own problems, but we have our very own issues to deal with direct emissions. But those may also be opportunities, as Rebecca was talking about, in terms of the smaller number of actors, et cetera. Before I describe our vision and strategies, let me share what I hope is a common set of facts, some of which have already been hit upon yesterday and today. Global population is growing, on its way to 10 to 11 billion people this century. All people deserve a better and more sustainable future. Society's current rate of consumption is unsustainable. Materials such as steel are irreplaceable in meeting human needs. There are over 10 tons of steel per person in developed economies, and developing economies have every right to have the same quality of life as those of us so fortunate to be in countries like the US. So therefore, steel production is expected to double by mid-century to meet growing demands. And fundamental changes in society take time, resources, and focused effort, which is why we're all here today. So, Brad wanted me to talk a bit about our vision to transition to low-carbon steelmaking. Our focus is to ensure that ArcelorMittal is not just successful today, but long into the future. We have a natural advantage in that our product is a critical material in today's world and has all the credentials to remain the preferred material for a sustainable future, including continuous recyclability, thanks to the relative ease of collection with magnets. There is also no need for downcycling, and steel's initial production phase energy and carbon emissions are much lower than some of our competing materials. We place a significant emphasis on innovation, research and development, to ensure we continue to lead the industry in product development and steelmaking process innovation. But today, business, and particularly heavy manufacturing, are facing increasing pressures to demonstrate that they can positively contribute to a world that needs to decarbonize if we're going to meet the targets set out in the Paris Agreement. For the steel industry, that is no easy task. Primary or integrated steel production occurs through a chemical reaction process, not merely heating and melting metal. That chemical reaction happens in a blast furnace where iron oxide is transformed using carbon in the form of coke and coal to separate oxygen from the iron. The result is liquid iron along with carbon monoxide, carbon dioxide, and other compounds. There is currently no replacement for carbon in that process. And I'd like to thank Rebecca for having great visuals for me because I don't have very good PowerPoint presentations at my fingertips. Today, about 70% of global steel production is through the integrated route. In the US, that ratio is flipped. Roughly 2/3 of production is through scrap recycling or in electric arc furnaces or so-called mini mills. One might think that all steel making can switch to 100% scrap recycling. Unfortunately, almost all scrap is already used, and stocks only make up less than 30% of today's steel production globally. By 2050, we think scrap stocks will increase to around 50% of global steel demand. Steel is the most recycled material in the world, with more scrap steel recycled than every other recyclable material on the planet. But there's not enough steel coming to its end of product life to feed growing global steel demand, particularly in the developing world. Therefore, decarbonizing steelmaking will depend on fundamentally changing how steel is made. It will involve advancing breakthrough technologies that either capture and store or reuse carbon, replace coal with alternative sustainable sources of carbon, or use electrolysis or hydrogen as an agent to reduce iron ore, hence removing carbon from the steelmaking process entirely. So what are our strategies to achieve this vision? I'll give you a high-level overview of some of our approaches and a little deeper dive on our exciting work with LanzaTech. But I should also mention we are developing a climate action report, which should be issued shortly. I had hoped it would be issued before today, because then I could really get into some of the deeper details. But in that report, we'll outline our current thinking, both opportunities and challenges, for our low emissions technology strategy. Excuse me. So our technology strategies and pathways. We're currently building several industrial scale pilot projects worth over 250 million euros based on smart carbon or zero carbon technologies. And you'll get in a minute why I'm referring to euros. Our partnership project with LanzaTech at our Ghent, Belgium facility to convert steel off gases to bioethanol. I'll get into a little bit more details about that. We're also in our Ghent facility implementing a Torero project, we call it, where we will turn 120,000 tons of waste wood into biocoal for co-injection into the blast furnace in place of coal. We also are developing what we call IGAR technology in Dunkirk, France, which reforms essentially waste carbon gases, CO2, and coke gas and natural gas to use as a reductant again in the blast furnace. As well as carbon, obviously hydrogen can also be used to reduce iron ore through, but essentially we'll need very large amounts of clean energy to produce the hydrogen, as well as the related hydrogen infrastructure. We are exploring this approach at our R&D center in Hamburg, Germany, and in March we announced a 65 million euro demonstration project to run a direct reduced iron or DRI plant on 100% hydrogen with annual production of 100,000 tons. In the US, we have joined with other steel companies, the US Department of Energy, and the University of Utah to test the use of hydrogen in a direct flash iron making project at a lab scale, but with the same basic premise, removing carbon from the steelmaking equation. This process uses fine iron ore concentrates for extremely fast reduction, obviating the need for coke, pellets, sinter, or other inputs. This still needs to be scaled up. And then iron ore can also be directly reduced by using electricity alone. With sufficient access to clean energy, electrolysis technology could pave the way to a carbon-free steelmaking. ArcelorMittal has developed this technology at our Mézeray Global R&D Center in France and demonstrated that steelmaking with electrolysis requires less power than the manufacturing of hydrogen from water. It's therefore very promising technology with the potential for deep reductions in CO2 emissions from steelmaking and could provide a more efficient alternative to hydrogen steelmaking. So I'll just move on to the LanzaTech project, which I'm very excited about and excited to be on stage with Jennifer. As Dr. Holmgren outlined, her company's developed an exciting technology with direct applicability to steel emissions, which is a big deal in our sector. The steel industry, and ArcelorMittal in particular, are proud of our application of circular economy thinking well before the term existed. LanzaTech offers us a technology to not only reduce overall carbon emissions, but to put it to even higher productive use the energy and resources we already use to make steel. As already mentioned, the steelmaking process creates energy-rich off-gases. Currently, we recycle many of these gases back into our processes, including for process heating, power, and steam production. With LanzaTech and other partners, we're now constructing a commercial-scale biofuel project at our Ghent, Belgium facility, which, to slightly correct Brad, will be the third commercial scale facility, with the DRI facility and then the China. China, I think, is a little faster on their permitting and other issues than the EU. So we're happy to be able to do the project in the EU. And we like to call the product that we create steel-and-all. Steel, ethanol, okay, so make sure you got it. This is the first industrial scale facility of its kind in Europe, and we're very proud of it. Once complete, the project is expected to utilize about 90,000 normal cubic meters of waste gas per hour, or approximately 15% of our waste gas. Annual production of bioethanol at Ghent is expected to reach around 64,000 tons of ethanol, or as Jennifer pointed out, about 21 million gallons per year, eliminating the greenhouse gas emissions of 80 million liters of gasoline, which is expected to yield an annual CO2 saving equivalent to 600 transatlantic flights, or installing 120 windmills. Production is expected to begin next year. The purpose of the industrial scale demonstration is to prove that biological conversion of waste gas into fuels and chemicals is scalable and viable. The GHG savings based on life cycle analyses show potentially greater than 80% reduction versus gasoline, without any impact on land use or food supply. LanzaTech has already shown some of its technology potential with the conversion to jet fuel, which is critical to lower aviation sector emissions. Imagine the myriad other potential value streams that we see as at least a triple benefit. First, providing a diversified product portfolio for steelmaking operations. Second, reducing direct steelmaking emissions by providing an economic way to eliminate flaring and otherwise used gases. And third, reducing emissions in other sectors by supplanting fossil-based fuels. We're excited about the possibilities for the future, but very mindful of the challenges ahead of us. Given the scope of these challenges, the reality is we cannot make the transition to low-carbon steelmaking alone. As the point has been made over and over here, policy, energy, and technology development will all be key to determining lower emissions pathways for steelmaking. As you can see, there isn't one single bullet approach for steel or many other sectors. And in the US, I am heartened that we're finally restarting this dialogue. I look forward to answering your questions and thank the sponsors again for the invitation to the event. Thanks.